The last component of tires here, we can look at this first set of diagrams. So we have a velocity in this direction, and we see there's a tire that is moving over this boulder. Now, when we zoom that up like so, we show is that the tire is exerting a force in this direction. The wheel is spinning this way, wanting to move to the left. And so we can see that motion like so. In this case, we call that adhesion, where there is a nice fit of the tire over the obstacle, over the terrain, which gives it a lot of surface area for a lot of traction, a lot of friction. This, of course, would be easier to attain when a tire is softer. A soft tire will have an easier time of doing that, but we've also seen what happens when we have soft tires. The soft tires result in underinflation, so there's a balance when it comes to getting this kind of tread. The next, we look at deformation, where the tire itself takes on a bizarre shape like so, because of the pressure exerted by the tire on the stone and vice versa. The tire bubbles, and so there actually aren't very many places of contact, and so we don't get very good traction. But in either case, this kind of deformation of the shifting of the shape of the tire, both through adhesion and deformation, causes wear on the tire. And so we see it here. It's being depicted on the leading edge of the tire, that as it is bent into this shape like so, little tiny flecks of the tire wear off, and that's how tires get worn over time. And when we look, just to bring this a little bit closer together, and this relates us back to the normal force and tire inflation. So here we have a very jagged road surface, and what we see is that there are points of contact like this. So where the red lines are indicate where the friction might be occurring. We also see there's kind of a sharp point going into the tire, but there's not a lot of point of contact. We have a small weight, small normal force, and the tire does not deform very much to fit. In the second case, we have a much greater normal force, and so we see much more deformation of the tire. And you can see now there is much, much more of the tire in contact with the road. And so what we see is that there is this dynamic balance between the force normal and the weight of the object and the tire inflation to produce friction for traction. In the case of the race car, we said before, if we saw the tire, there was very little in the way of grooves. If the road is very flat and the tire is very flat, there is lots of contact, lots of friction. The bumpier the road, we need to make allowances in terms of tire inflation and tire tread to get the ideal amount of friction. So this is some of the ideas related to tires and friction.